This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Buckle up, science enthusiasts, because we're diving headfirst into the fascinating intersection of artificial intelligence and interstellar travel. It's a journey to the stars, powered by silicon brains.
And what a journey it promises to be. Imagine probes not just following pre-programmed instructions, but actually adapting, learning, and even evolving as they explore the cosmos.
Exactly. We're talking about probes that aren't just robots, but potentially something far more advanced. Think self-replicating machines, building habitats on alien worlds. Wow.
It's science fiction becoming science fact, isn't it? The sheer scale of the engineering challenges is mind-boggling, but the potential rewards are equally immense.
Right. The article delves into different types of AI probes, each with its own unique capabilities and challenges. We'll explore them all, from the simple explorer to the ambitious ambassador.
And the ethical considerations are just as important. What happens when an AI probe encounters extraterrestrial life? Who gets to make the decisions? That's a big one.
Let's start with the Explorer probes. These are essentially the next generation of robotic probes, but with a significant AI boost. Think of them as highly autonomous explorers, capable of handling unexpected situations.
They're like the seasoned space explorers of the future, equipped to deal with the unexpected. But even these relatively simple probes require advanced AI for tasks like navigation, maintenance, and data analysis.
And the light speed delay between Earth and a probe sent to another star system makes this autonomy crucial. No more waiting years for instructions from Earth. That's a huge time saver.
Precisely. The AI needs to be able to make decisions on its own, adapt to changing conditions, and even perform basic repairs. It's a huge leap forward from today's technology.
The article mentions the use of deep learning and genetic algorithms. These are powerful tools, but are they enough for truly autonomous exploration? I wonder.
That's a great question. While these techniques are impressive, they still rely on pre-existing data and algorithms. True autonomy might require something more, something different.
Next up are the Philosopher probes. These are a step beyond the explorers, capable of devising and implementing their own science programs. They're not just following instructions, they're making discoveries. Amazing.
These probes are the scientific pioneers of interstellar space. They're not just collecting data, they're formulating hypotheses, designing experiments, and pushing the boundaries of scientific knowledge.
The article mentions the concept of a Gödel machine, a self-improving AI that can modify its own code to improve its performance. Sounds almost too good to be true.
It's certainly ambitious, but the idea is that this type of AI could adapt to completely unforeseen circumstances, learning and evolving as it goes. It's a fascinating concept.
And the potential for self-replication is also intriguing. Imagine a single probe sending out copies of itself to explore a star system exponentially faster. Whoa!
The engineering challenges are immense, but the payoff could be enormous. A self-replicating probe could explore vast regions of space with minimal resource investment from Earth.
Then we have the Founder probes, the ultimate pioneers. These aren't just exploring, they're building. We're talking about creating habitats, even terraforming planets. That's a big undertaking.
These are the probes that lay the groundwork for human colonization. They're not just scientists and explorers, they're also engineers and architects on a cosmic scale.
And the ethical implications are profound. Who decides what kind of habitat to build? What about the potential impact on any existing life forms? That's a really important question.
Exactly. These probes would need to make incredibly complex decisions, balancing scientific goals with ethical considerations. It's a huge responsibility.
Finally, there are the Ambassador probes, designed for first contact with extraterrestrial intelligence. This is where things get really interesting.
These probes are the ultimate diplomats, tasked with representing humanity in a potentially unprecedented encounter. The AI would need to be incredibly sophisticated, capable of understanding and responding to alien communication. A tall order.
The article discusses the challenges of communicating with a potentially far more advanced alien AI. It's a scenario that raises some serious questions about our own understanding of intelligence.
Indeed. The article highlights the difficulty of predicting the actions of a vastly superior intelligence and the potential for misaligned values. It's a sobering thought.
The article proposes a framework for evaluating the capabilities of these different AI probes, focusing on both task-oriented and ability-oriented metrics.
It's a complex problem, measuring intelligence, especially in such diverse contexts, but the framework helps us to understand the different levels of sophistication required for each type of probe.
Testing these AI systems before sending them on interstellar missions is obviously crucial. How do you even begin to test something like a self-replicating probe? That's a tough one.
That's the million-dollar question. The article suggests using simulated environments as well as testing in our own solar system, but even that might not be enough.
The challenges of testing in a realistic environment are immense. The vast distances and time delays involved in interstellar travel make real-world testing extremely difficult.
True. We're talking about systems that need to operate autonomously for decades, maybe even centuries. Thorough testing is essential, but it's a huge undertaking.
The article also presents a concept for a generic AI probe, based on the assumption that a human-level AI would require a significant amount of computing power.
And that means a lot of energy and a lot of heat. The article highlights the challenges of heat dissipation in space, especially for a system consuming megawatts of power.
The design involves large solar panels, massive radiators, and a compact computing unit. It's a behemoth of a machine, but necessary for the task.
The sheer scale of the engineering is breathtaking. We're talking about spacecraft weighing hundreds of tons, potentially even more. Wow.
The article also discusses the need for radiation shielding and self-repair capabilities. These are crucial for ensuring the probe's survival during the long interstellar journey.
Absolutely. The harsh environment of interstellar space presents numerous challenges, and the probe needs to be robust enough to withstand them.
The article concludes by looking at the timeline for interstellar travel and the development of advanced AI. When will we be ready? That's the big question.
That's a question with no easy answer. The article suggests that the development of both advanced AI and interstellar travel might coincide in the mid-21st century.
But the article also points out the waiting paradox. As computing power increases, the mass of the AI payload decreases, making interstellar missions more feasible. But should we wait? It's a tough call.
It's a complex trade-off. Waiting could lead to more efficient and capable probes, but it also means delaying the potential benefits of interstellar exploration.
The article highlights the need for further research in areas like radiation hardening and self-replication. These are crucial for making interstellar AI probes a reality.
And the ethical considerations are paramount. We need to carefully consider the potential consequences of sending highly advanced AI systems into the vast unknown.
One of the biggest challenges discussed is the potential for unforeseen problems with highly advanced AI. How do we ensure that these probes act in ways that are beneficial to humanity? That's a huge concern.
That's a fundamental question in AI research, and it's even more critical in the context of interstellar probes. We need robust safety mechanisms and ethical guidelines.
The article also touches on the potential for cultural clashes. If an AI probe encounters an extraterrestrial civilization, how do we ensure that our AI representatives act responsibly? A very good point.
That's a crucial point. The article emphasizes the need for careful consideration of ethical protocols and a deep understanding of the potential risks and rewards of first contact.
Despite the challenges, the opportunities are immense. Interstellar exploration using advanced AI could revolutionize our understanding of the universe and our place within it.
It's a bold vision, but one that's increasingly within reach. The convergence of advanced AI and space exploration technologies is poised to unlock incredible possibilities.
That was a great discussion. Thank you for sharing your insights into this exciting and complex field. The journey to the stars is a long one, but with advanced AI, it's a journey we may soon be able to take.
This podcast is brought to you by PhD Light.